So with the assembly manual opened up to the page for building the IO expansion, let's go ahead and start to sort through things and do some soldering. So it says there's four 4.7k ohm resistors. It's most likely these. I'm just going to go ahead and measure them. Not 100% sure looking at the color codes, but of course the meter will tell us. Yeah, 4.7K. I'm guessing they're labeled in the silk screen. 4.7. 470. Now let's see if he tells us where to solder them in. So really it's just find the locations and solder. I actually cleaned the bench here up and all the tools are back organized. And on their little strips, magnetic strips, up out of camera shot here. Kind of nice to have the bench cleaned up. So there's the 4.7K. I see two up here. I tend to start with the lower profile components because I can flip the board over and they're kind of pushed into place and work my way up the board. Not everybody builds that way. Really, whatever works for you is of course acceptable. So there's two of them. I had spotted a third one right there, 4.7K. I know I say this in every build video, but I am putting the color bands in the same orientation for the resistors. It actually doesn't matter. Resistors are not polarized. It just makes for a slightly better, in my opinion, looking build. You know, and this board will be hidden away in a case. Nobody will see it but me and you. But still, I just think it makes for a nicer build. So that should be the 4.7K. Soldering here. Just pressing down on the board, hold the resistor up tight. Apologies for the washing machine behind me. I know it's extremely irritating in the video or the audio, but life has to go on. We have a 470 ohm, which, looking at the resistors here, is going to be that guy. And we'll double check him, but that one I can see the color codes on quite clearly. Yeah, 458 ohms. It's the 470. It's within, I'm sure, the tolerance. The resistor, I spotted him earlier right here. There you go, little resistor lead. have 150 ohm. This guy right here, brown, green, brown. 1.5 followed by 1.0 or 150 ohm, but again, I'm just going to double check. 151 ohm, that is certainly him. And the 150 goes right here. And we have an 82 ohm. It says black, gray, red, black. There's a 220. Should be 100K in here, which is right here. Brown, black, yellow is the 100K. That's a 220 ohm. This must be the 82 ohm. 81.9. Ohm, where do you live? There's the 220, the 100K, so there's right there one more resistor floating around, which goes right here. This is a 220 ohm, red, red, brown, 2.2 followed by 1.0. 220 is sitting up here, and that's the same orientation. The other one running horizontal is in, and that is a brown, black, yellow or 100K. And he lives right here. Not happy with that solder joint. Got a big old blob of solder. Didn't have the tip clean. Not happy with how that soldered up. I am again using kind of a larger tip here on my soldering pencil, which is, you know, if you're using a Weller or, you know, an inexpensive pencil, I think this tip will be a little closer in size to what you would be using rather than the really fine tip I prefer to work with, just because I think it gives a little more accurate representation of what the build might be like for you. So, nice little set of resistors. PCB is well marked, so silkscreen. Everybody I was expecting was there in the packaging, which is appreciated. So he moves us on next to the capacitors. I'm actually going to change the order here. I'm going to go to the IC sockets because the capacitors tend to stand taller than the IC sockets. Again, this is just personal preference. I've got tape to just kind of tack those down so I can flip the board over. These solder corner pins, check for flush. My washing machine's telling me this load is done. just a bit of pressure. Reflow the solder. Just to make sure the socket's flush. It's just a little bit nicer build. And we can walk through those solder joints. I'm actually going to swap glasses out here. This may be a little too, might be a little too much at the moment. That's better. I've hit that wonderful age where, of course, my eyes are getting older, don't focus, and as they fatigue throughout the day, they focus even less. So it really is kind of a crapshoot which glasses are going to give me a focal length I can work in without hopefully getting my big bald head, well, balding head, in frame. Nice PCB. You know, the layout is reasonable. It's through hole. There's lots of room. I'm not fighting to get around pins to create bridges, that kind of stuff. It's sized to, you know, the lengthwise here is sized to the back panel where all the connectors go. So, you know, he's taking advantage of the room. You know, potentially this board could have been shallower. But no, you know, give us lots of room to work. You know, there was no reason for it, I think, to be shallower, especially with the mounting holes out here. So, you know, nice job. I like a board. It's a good, clean layout with lots of room. Make it easy to solder. It's going into a large case. I just think it was a good engineering call. Inspect all those solder joints. I've hit every one. There's one right there I don't like the looks of. It looked a bit cold. Happy with that. Now the capacitors, there's 7.1s or 100 nanofarads. That's a 104, that's a 0.1 microfarad or 100 nanofarad. These are typically logic to spiking capacitors, you know, for dealing with power supply rails, although you may also be using them for other things on the board. 104. And there should be one more. I actually don't see one more. There's the 3 tantalums, the 227 picofarad, the crystal, 7 times 100. So it looks like I was short a capacitor, not a huge deal. I may actually use some capacitors I already have and save those just because they're small. So, you know, the roundies, the older looking technology caps. 1, 2, 3, 4, 5, 6, 7. Yeah, there's 5 of them around the Max 232. 4 of them are used in the converters to get the plus and minus 12 volt rails from the 5 volt, and I'm sure one of them is despiking. So we are short one. Well, I'm going to grab, so I'm going to step away here for just a second. I'm just going to substitute capacitors I already have. Sometimes in projects that are, when it's visible, I like kind of the old style caps, just because they make things look a little more period accurate. I should have a number of them in here with the proper lead spacing, hopefully. There's 1, 2, 3, 4. This is a mix of different lead spacings. 5, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And I'm just going to go ahead and drop these in here, get them captured. Probe leads are going with me. These are out of a large bag of surplus caps I bought years ago. Again, they're labeled 104, so they're 0.1 microfarad or 100 nanofarad. Prefer the orientation of these to be the same. These little ceramic caps like this are not polarized, but I still prefer them all to face the same direction on the PCB. It's just kind of me being potentially too anal. Of course, it just kind of forced me to think about it for every component I put in, because there are polarized components. We'll get to those tantalums in a minute. And the LED is polarized, so you do need to think about it. And maybe for me, thinking about it for every component just forces discipline. I have in my time blown up a couple of tantalums by getting them in backwards. 5-volt circuit like this, I wouldn't expect a tantalum to fail, but I've had higher voltage stuff where I get one backwards, apply power, and boom. Really exciting. Really smells bad. Now, in these cases, caps I chose to use are a little bit lower profile than the sockets, but that's okay. Might have been better to do these a couple at a time rather than hit them all at once. But such is life. I'm just going to hit one lead on each cap, then take a look at the front of the board just for kind of squareness and even heights. Clean anything up I'm not happy with, and then we'll finish soldering. Not happy with that one. Those two look fine. Those look fine. Let's hit the other leads and be done with these. Like I said, 4 of these are around the max 232, and those are for the charge pumps that take the 5 volts coming onto the board and convert it to plus and minus 12, so you get true EIA level RS-232 signals. A lot of stuff relies on the fact that RS-232, at least modern RS-232, is really forgiving for the voltage levels, and they just take advantage of that. But if I'm going to be hooking up, say my televideo terminal or another vintage terminal from the area or the era, I really do want proper voltage levels on the RS-232. And of course, one of the leads has got to be in the way. away here. And over into the pile of stuff. IC sockets, LED with the long lead to the right. And of course there is a flat in this package which aligns with the flat in the silk screen, long lead to the right. Same exercise, I'll solder one side. Check to make sure he's flush, which he's not. Add the jacks and connectors. The 10 microfarad tantalums. So I'm a little bit out of the order here. He had us doing this, and there's the two 27 picofarad ceramics. These are both labeled 2.7. They are part of the oscillator circuit for the 8 megahertz oscillator that drives the system. They're a little tiny. Flex the leads out. Exact same exercise. I'll solder one side, take a peek, solder the other. They look good. Certainly hear the rain outside. It's beating down on the skylights. It has definitely turned into fall here in the Seattle area. So we've got 3 tantalums. They are polarized. Plus lead is typically marked. I'm having a hard time seeing it here. Yeah, long lead in the plus hole. Yep, long lead is labeled plus. Long lead in the plus hole. Again, nice job on the silk screening, the large white fill for negative, and a plus sign for the positive side. So nice. I like nice clear silk screening where there's been some thought go into it. I thought he was in there stiff enough to hold himself in place, but he obviously wasn't. One of these tantalums is for the charge pump. Well, I shouldn't really call it a charge pump. The PIC 25 MX 100 and 200 series, where they're in the DIP packages, the CPU core voltage is 1.8, but you feed it 3.3 volts. So it's kind of 3.3 volts compatible to the world, but the internal core is 1.8, and there's a tantalum cap, 10 microfarad tantalum low ESR, that's used as part of the power supply circuit, where in the PIC processor itself it does the the voltage regulation to get down to 1.8. And that would be this cap right here based on the PCB layout. So it's an important capacitor. It's an important capacitor to get a low ESR device in. So that's all good. IC sockets, LED, the 3.3 volt voltage regulator. This guy right here. Bend the leads a little bit more into the triangular footprint. Nice, easy board for assembly. Like the documentation. I'm just going to hit one pin, come back, check it for square. is a device to be careful with. The pins are very close together. I'm going to give him a slight twist so he's square to the silk screen, just because I can. Looks a little neater. Solder in the 2 pins I missed. Then I'm going to, because I twisted the package slightly, I'm going to reflow the original lead I soldered. And that way, if there's any mechanical stress from the twisting, it should be released. So, clip these leads out of here. It's really got all the discretes. Very happy with that. Very happy with how it came together. I think we'll wrap this video up here. I'm going to take a little break. When you're soldering, I recommend breaks. Come back with the mind a bit focused. I definitely like a cup of coffee, but we'll pick up in the next video with all the connectors. Actually, there was one more thing he soldered in this portion, and that is the 8 megahertz crystal itself. So let's go ahead and actually do that before I end the video. Solder one side. I know he's sitting very crooked. It's okay. And everything I've read about this 32-bit PIC in a 28-pin package, it's really accessible for through-hole construction. It's not surface mount. It gives you a lot of power. In an easy-to-use package, I just see huge amounts of upside to it. So I started in the video with, I just can't program it. Anyhow, I will actually wrap this up now. There's all our discretes. I'm happy with the build. We'll pick up the next video and look at connectors.